Right, in part C, we're going to rotate this region around this horizontal line, y equals -1. So I'm going to show the disk method, which would require vertical rectangles of representation. And we'd have to do two separate integrals, one for the region as x goes from 0 to whatever this x value is, c, and the other one as x goes from c to this x value, which is a. I'm going to go ahead and draw the major disk and the disk that is the whole, represented rectangle, dx, and focusing on the radius from the green line all the way to the outside, which is the blue curve, we're going to get this one solid disk. We'll do that one separately, and then we'll subtract the whole. And then we're going to have to repeat the process for the yellow region. So we have the y value of the top curve, which is square root of x, minus the y value of the center, which is -1. That will give us the outside radius from the green line to the top, which gives us the volume of this entire disk. Pi times radius squared dx. And now we'll subtract the whole. We're going to subtract this disk, which will be the whole, and that will give us the washer that represents the blue part of this entire region, just the blue part rotating around the line y equals -1. All right, let's subtract the whole. So pi radius squared dx, and the radius of the small curve is the distance from the center of the disk to this edge. And this edge is defined by this blue curve, which is the negative square root of x. So that takes care of that, and that'll do it. And we could have written this as one integral, and I'll go ahead and do that now. Alright, so the disk's, or I should say the washer's volume is pi times outside radius squared minus inside radius squared dx. And that will take care of the solid of the blue part. Now we need to add the yellow part. So just like for the blue region, the volume of this solid revolution rotate around the green line will be pi r squared dx, but it'll be the outside radius squared minus the inside radius squared. So the outside radius squared will be the distance from the blue curve to the green line. Looking at a represented rectangle, the outside radius will be from the green line to this part, so this y value minus this y value. Square root of x, that's that y value minus the green y value, which is -1. And then for the inner radius is this distance. So this y value minus that y value. And this y value is x squared minus 1. Minus the y value of the green line. This y value minus that y value gives you that inner radius. All right. That does it. The volume of that solid revolution of this entire yellow region rotate around the green line will be the sum of these two definite integrals. This is actually the washer method, and we didn't need to evaluate it. They just asked us to set it up. So just doing a couple little simplifications, this would be my final answer.